So in 11.4, we talked about nonlinear inequalities. You're going to find that 11.5 is super similar, but because these are rational inequalities, we have those fractions we have to deal with. And so we do have a few differences that we have to deal with. Now, there's no real notes per se, so we're just going to jump in and do some homework problems together, and then you can use those as your guide as we go through these. So everybody, let's take a look at problem number 1. Now, you might notice that, it's similar to what we did yesterday. The first thing that I want you to get in the habit of doing is putting the top and the bottom in parentheses, so those factors in the top and the factors in the bottom are really sticking out to you. Now, for this to work, we want this to be related to 0, which it is. If it is not, like number 3, we will fix that. But our first one here, we have the top is in factored form, the bottom is in factored form, it's related to 0, and that's our goal. Now, when that's the case, what you're going to do, just like we did yesterday, we're going to take each factor, we're going to set them equal to 0, and we are going to solve for the zeros. Okay? Just like yesterday, we are going to make a number line chart. We're going to put those numbers down in least to greatest order. Now, here is the difference. If our factor comes from the bottom, if it is the denominator factor, any denominator factors, no matter what, always get an open circle. Now, the reason that's the case is a denominator is never allowed to equal 0, and that is a 0 from our denominator, so all denominator zeros have an open circle. Any zeros occurring in the numerator, they will be open or closed based upon the symbol that's given. Okay, so all denominators are always open, but numerators are dependent upon the symbol in the problem. This is a less than symbol. It doesn't have that equal to bar in it, so it is also open. Don't expect that they will always be like that. Sometimes you'll have an open and a closed, and so on. Okay. Now we're going to make the rest of the problem is exactly like before. We're going to make that chart. So we're going to extend these. We're going to put the factors from the top and bottom on the side. We're going to find some test values. Let's go 0, 2, and 8. It can be any values within the region less than 1, between 1 and 7, after 7. So I chose 0, 2, and 8. You might choose completely different values. That's okay. Okay. Now we're going to plug them into the factors like we did for the nonlinear inequalities. If you plug 0 into the top, you get -7, so that's a negative value. 0 minus 1 is also a negative. Now remember, a negative times a negative is a positive. A negative divided by a negative is a positive. They work the same way. So a negative divided by a negative is a positive. Now let's look at 2. If I plug in 2 to both of those values, 2 minus 7 is a negative. 2 minus 1 is a positive. A negative divided by a positive is a negative. And then lastly here, if we plug in 8, we get a positive and a positive, which is a positive. And then now we're going to go back to our symbol. This says less than 0. Less than 0 means that we have a negative values that we're searching for. So color in the negative region or regions. And that is our answer. So our answer is the x is between 1 and 7. Now, I don't want you to write it in inequality form. I want you to write your final answer in interval notation. So we want the x's between 1 and 7. Now, remember, I use parentheses for any open circles. I use a bracket for any closed circles. Any questions about what you see there for problem number 1? Okay, so let me go over the rules again. We want to factor the top and bottom. It always has to be related to 0. Any factors on the top are open and closed based upon the symbol in the problem. Any factors on the bottom are always open because they can never equal 0 because they are a denominator value. Then we make the plus or minus chart, find some test values, determine whether we want positives or negatives based upon the symbol in the problem. Okay. Now that we have note 1 done, what I would like to do is I would like to look at number 3. Now, 3 is different because it's not related to 0. It's related to this 3 here. We don't want that. So the first thing we have to do is fix that. And we're going to fix that by subtracting 3 from both sides. Now, one piece is factorable. One piece is not. Let me say that again. One piece is in factored form. One piece was a whole number, not really factored or anything. It's just the number 3. So put it over 1. And the reason we have to do that is we cannot proceed with this problem until we only have one fraction in the problem. We can't have 2 things here. So to add these fractions, just like the first problem, surround those by parentheses. And we're going to have to get common denominators. So we have that x plus 6 there. We're going to multiply here on top and bottom by x plus 6. Now, what that's going to do is that's going to allow us to combine the fractions because our new denominator will be x plus 6. But our numerator, in order to add or subtract fractions, we keep the bottom, x plus 6. We add up the tops. So our tops are x plus 32 minus 3 times x plus 6. Now, that 3 times, that negative 3 times, needs distributed. So let's distribute that to save us room since we don't have a ton of room here. That would be negative 3 times x, negative 3x. Negative 3 times 6 is negative 18. And then if we mush all the junk together, we get negative 2x plus 14 all over x plus 6. And we're not done until that is in factored form. So on the top there, both of those pieces are divisible by negative 2. So our final factored form would be negative 2 times the quantity of x minus 7 over x plus 6 is less than or equal to 0. Okay, so let me remind you exactly what happened again. I moved the 3 to the other side by subtracting it, put it over 1 so it looks more like a fraction. Got a common denominator of x plus 6. Anything that was left, I need in factored form. Okay. Now, just like before, we are going to set each one of those factors equal to 0 to find the zeros of the problem. Well, negative 2 is not going to equal 0. It's going to have to be accounted for, but it's not going to equal 0. But x minus 7 equals 0 at 7, and x plus 6 equals 0 at negative 6. So on our number line, in least to greatest order, negative 6 comes first, then 7. Okay. Now, the x minus 7 factor came from the top. So since it came from the top, it is determined by the symbol in the problem. The symbol in the problem had the equal to bar in it, so that one is going to have a closed-end dot. If it comes from the top, just look at the symbol. If the symbol has the equal to bar, it's closed. If the symbol doesn't have the equal to bar, it's open, just like the problems we had done in 11.4. X plus 6 came from the bottom. This factor came from our denominator. It is always open no matter what. So any factor from the bottom is always open. Any factor from the top is determined by the symbol in the problem. Okay. Now, just like before, we got to make a little chart. So now that hard part's kind of over with. But we have a factor of -2, a factor of x minus 7, and a factor of x plus 6. Now, since -2 is a number, it is always either positive or negative. In this case, it's always negative. So I'm just going to put a little negative, negative, negative. No matter what, -2 is negative. If it was +2, I'd put plus, plus, plus. Okay, but it's a negative. Now we need test values. So let's find our test values. Let's go -7, 0, and 8. Okay, and now let's plug them in to our remaining factors. If we plug -7 into both of them, we get a negative and a negative. Now this time we have 3 negatives multiplied or divided or whatever. 3 negatives, whether they're multiplied or divided, will get you a negative answer. If I plug in 0, I get a negative and a positive. 2 negatives multiplied together give me a positive. And then finally, if I plug in 8, I get a positive and a negative. We have 2 negatives on the list there, and so we have an even number of negatives. That's going to be a plus. No, we don't. Wait a second. Let me think about that one more time. This one, 8 plus 6, last I checked, was a positive. Like, wait, that doesn't seem right. And a 1 negative will stay negative. Sorry about that. Okay. So now we go back to the problem. This was a negative symbol, a less than. Less thans mean that we are looking for negatives. So we're going to color in the negatives. So now we have our answer. So we want x's that are less than -6 or x's that are greater than or equal to 7. You'll notice that the 6 has no equal to bar on it, but the 7 does, because the 7 came from the top and this -6 came from the bottom. In interval notation, our final answer would be, this is going from -infinity to -6. So we would go from -infinity to -6 with a parenthesis. And then this one goes to infinity. So this one has a bracket on the 7 to infinity. So there's a lot there. Okay, so let's just talk about again one more time. If it's not related to 0, you're going to move the number to the other side, get a common denominator, get it into factored form. Any factors from the top, it's either closed or open based on the symbol. Any factors from the bottom are always open. Okay, now let's do one that is not in factored form. We're going to do, we're still going to do 2 more at least. Okay, so let's do number 6, and because it's not in factored form. Yeah, let's do maybe 6 and 8. I don't know. Okay, let's start with number 6. So the first thing you always look for, is it related to 0? Yes, bam, that's good. Okay, but it's not in factored form. Put any factors in parentheses. The factors of 24 that have a difference of 5 are 8 and 3. 8 times 3 is 24, but 8 and 3 subtract to 5. So this is going to be 8, x minus 8 and x plus 3. Now that it's in factored form, we're good to go. We're great. It's awesome. You're going to set each factor equal to 0 and solve. So our first one is x minus 8 equals 0 at 8. X plus 3 equals 0 at negative 3. And x plus 6 equals 0 at negative 6. So we're going to put those on our little number line chart from least to greatest number line order. We're going to make that into a chart. Now let's talk about whether or not we have open or closed circles. The factors from the bottom, x minus 8 and x plus 3, are always going to be open no matter what. So 8 is open and negative 3 is open. But any factors from the top, we have to look at the symbol in the problem. So at negative 6, the symbol tells us that we're allowed to equal that. So we're going to put a closed-in dot there. Okay, so any factors from the bottom, don't worry, I'll always make it open. Any factor from the top comes from the symbol in the problem. Okay, now in our chart, we had 3 factors, x minus 8, x plus 3, and x minus 6. We have to figure out some test values. It can be anything in that region. To the left of negative 6, why not negative 7? I noticed on one of the problems yesterday, you had to choose like a decimal because there was, it was like somewhere between negative 1 and negative 2, so negative 1.5, you know, just something in that region. So if you have to choose a decimal, you have to choose a decimal. Here, let's go negative 5, 0, and 9. So let's plug them in. Okay, so first let's start with negative 7 here. So I'm doing this region right there. If I plug negative 7 in, I get a negative, and a negative, and a negative. 3 negatives are going to multiply and give me, or divide, and give me a negative. Okay, now let's plug in negative 5. If we plug in negative 5, we get a negative, and a negative, and a negative. Wait, did I do everything right? Let's see here. Thank you. Yes, I'm like, something's wrong. What did I do wrong? Oh, that's an x plus 6, which would make this one right here. Would that be a positive then? Yeah, okay, so that one ends up being a positive. So 2 negatives make a positive. Sorry about that. That's what you get for not writing it down right. Now, if we plug in 0, we get a negative 8, a positive 3, and a positive 6. 1 negative keeps it a negative. And then if I plug in 9, I get a positive, and a positive, and a positive, which is a positive. Okay, now go back to our symbol. Greater than or equal to 0 means that we are searching for positives. Greater than 0, positives. So color in your positives. And our answer are the x's between negative 6 and negative 3. The negative 6 has an equal to on it, but the negative 3 does not. And then we want x is greater than 8. Now let's put that in interval notation. We want x's from negative 6 to negative 3. The negative 6 gets a bracket, but the negative 3 does not. Or is just a union symbol. And then we are going from 8 to infinity. Okay. So that is problem number 6. Okay, so that's problem number 6. We're going to do one more together. Let's do problem number 8. Okay. So just like the one that had the 3 on the other side, this one does not have a 0. So this thing here needs to scooch over to the other side. Now, one thing I notice is it's a negative. So when we scooch it to the other side, it's going to be a positive. And I'm just going to actually set it in front of that because it's going to be positive. Okay. So the first thing you want to do is make it look like this. So I've just moved it to the other side. It changed sign. It became a positive. So I put the positive thing first and the negative thing. You didn't have to. I just did that. Okay. Now, we can't do this problem until we only have one fraction in the problem. To combine fractions, we must have common denominators. So put your denominators in parentheses. Any other factors that had more than one term, parentheses. This fraction needs an x plus 7 that it doesn't have. So multiply that on top and bottom. This one needs an x plus 8. Multiply that on top and bottom. Okay. So how do we add or subtract fractions? Well, we add or subtract the tops, keep the bottom. So our bottoms are going to contain x plus 7 and x plus 8. To combine fractions, you get to keep the top or keep the bottom and add or subtract the top. Now, how do we combine these tops? Well, this is 4 times x plus 7. To save us time and room, let's do that multiplication. 4 times x plus 7 is 4 times x and 4 times 7. Now, be careful here. This is really negative 3 times x plus 8. So let's take the negative 3 and distribute that. And we get negative 3x minus 24. Now, if you combine up the like stuff on top and make that prettier, we get x plus 4. Now, x plus 4 is great because it's not factorable. Just put it in parentheses. And now it's ready to go. So again, if it's not related to 0, move the thing to the other side, get common denominators, combine the fractions. We're done. We're ready. Okay. So now it's ready to actually do what we've been doing from the very first problem. We're going to set each factor equal to 0. Bless you. This gives us negative 4, negative 7, and negative 8. We're going to put those on the number line from least to greatest order. Number line order. The factor from the top, this one. We have to look at the symbol that was in the problem. The symbol in the problem had the equal to. It gets an equal to. But the factors from the bottom are always open. Okay, let me say that again. The factor from the top is open or closed based upon the symbol in the problem. This one had to be closed. The factors from the bottom, no matter what, are always open. Okay, now we're ready to make a chart out of our box. So we have factors of x plus 4, x plus 7, and x plus 8. Let's get our test values going. So I'm going to have to use like negative 9, negative 7.5 should work, negative 6, and 0. Lots of negatives for this problem. So let's plug those in. Let's see what we get. Okay, if we plug negative 9 into every single piece, we get negative, negative, negative. 3 negatives make a negative. Now let's plug a negative 7.5 into every single one. If we plug negative 7.5 in, we get negative, negative, positive. Two negatives flip to a positive. Next, we're ready to plug in -6. If we plug in -6, we get a negative here, but positives both of those. One negative stays negative. And lastly, we need to plug in 0. If we plug in 0, we get plus, 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 which stays positive. Now look to our symbol. This symbol means less than 0, that we are searching for the negative regions. So color them in. So we're ready now to put our answer down on paper. So how do we write this answer? Well, we're going to start at -infinity. Well, we'll do that in a second. Let's do with the inequality first. We want all x's that are less than -8, or x's that are stuck between -7 or -4. Now you'll notice I put an equal to on the -4 only. It's the only one that had an equality there. Everything else are open circles. So now let's do our interval notation and we're done. So we get, starting at -infinity, we stop at -8, put a parenthesis there for that open circle. And then we go from -7 to -4, put a bracket on that one. Okay, so that should give you a really good idea of how these problems work. Please look at number 10 below this one. You might notice that we have a squared on that one. When you do make the chart, remember to include that square, because the power will make everything positive in a wonderful, lovely way. 7 and 9 are exactly like 6. You're going to move that over and get common denominators. Follow the exact same pattern we did with number 6. And if you follow that, you should be good. 4 is exactly like 3. So 1 and 2 are the same kind of problem. 3 and 4 are the same. 5 is actually like the first one. It's pretty, 5 is nice. It's all but set up for you and pretty. And then these two are like that one. And then this one is kind of like the first problem. It's not hard. Just remember when you have a square that to include that in your chart.